How y'all doing? Yeah, please be sure and put your name in chat and pin my screen. Because when you pin my screen, you can see whatever I write over here a lot better. I think I'm supposed to have 18 in this class. Okay. Bear with me. Okay, please be sure your name is in chat and make sure you pin my screen. That way you can see what I'm doing better. All right, this got caught off a little bit. It says rational function. So that's the only thing that got caught up over there. And I just noticed this about this graph here. Okay. Anyway. We will talk about graphing. Where is it? Rational functions. What the devil's going on? All right, we're gonna discuss. Last time we dealt with graphing. Where is it? last time we dealt with graphing, oh, did we do this function already? I think we did. We did this function last time. Yeah. So what I'm going to have to do is come up with a different function. So if we have the function x squared plus 3x minus 10 being divided by 2x squared minus 6x plus. This is my rational function. The textbook will use a lowercase r, an uppercase r here. I just use f of x rather than r of x. It doesn't matter. It means the same thing. So first thing we want to do is to see if this is reduced form. So we factor everything. And the leading coefficient is 1. So that means our two binomials are going to be x and x. So the factors of 10, that subtract to 3. Well, that's 2 and 5. And to get a positive 3, it has to be 5 minus 2. And factoring this here, okay, I'm gonna do it over here real quick and then end up erasing it. So my leading term is 2x squared. So I'm going to use my Berry method, my down under method, my Australian method, and put 2x and 2x. And because I have an extra 2 in there as a factor, I'm going to divide 2 out. That means one of these two binomials, 2 will divide quite nicely. And so now I'm going to do 2 times 4, which is 8. And the factors of 8 that add to 6 are 2 and 4. But to get a negative 6, they both need to be minus. So it's going to be a minus 2. And a minus 4. Wait a second. Is that right? Did I do, this would be x, not be a negative. Oh, that's not a negative 6. It's a -7. My apologies. No, it's a -9. Sorry. Apologize again. All right. So the factors of 8 that add to 9 are 1 and 8. And so it's going to be a 1 and an 8. It doesn't matter where I put them. And they both have to be minus to add to a negative 8. And so 2 divides this one quite nicely. So this gives me 2x minus 1 times x minus 4. And so this, I'm going to write x minus 4 times 2x minus 1. Now I have no factors in the numerator that are the same as the factors in the denominator, so I don't have any ones that come out. So it is in reduced form. And the factoring does 2 things for us. It helps us get to a position where we can find the vertical asymptotes. It also tells us if it's in reduced form or not. Because we can't list the vertical asymptotes unless it's in reduced form. Since there's no factors that are the same that go to 1, then the vertical asymptotes depend upon the denominator. Wherever the denominator is 0, the function does not exist. So we set each of these factors equal to 0. So we get x equals 4 and 2x equals 1, or x equals a positive 1/2. So at 4, 1, 2, 3, 4, I have a vertical asymptote. And at 1/2, I have a vertical asymptote. So that means as x approaches those values, the y value either goes to negative infinity or positive infinity. Now we need to determine the horizontal asymptotes if it has any. So for the horizontal asymptotes, we look at the leading terms. Y equals x squared over 2x squared. Are the degrees the same or different? If the degrees are the same, then it is y equals 1 over 2, the leading coefficients. N equals 1, 2 equals 2. If this was a 1 up here, then it would be y equals 0. So at y equals 1/2, that's this horizontal line, y equals 1/2, is this horizontal line, we have a horizontal asymptote. And I usually graph them as I find them rather than I find them and then I graph them. But that's just a matter of choice. It doesn't matter. At this point, we have this graph so far. Now we list the x-intercepts. The x-intercepts depend upon the numerator. I set the numerator equal to 0. That's x minus 2 times x plus 5. So I'm going to set x minus 2 equal to 0. And I'm going to set x plus 5 equal to 0. And that will give me my x-intercepts. At x equal to 2, I get 0. And at x equal to -5, I get 0. So that's -5 and 2. So at -5, 1, 2, 3, 4, 5, I have a 0. And at +2, I have a 0. Now to find the y-intercept, I look back to the original equation, or I could do it here. And if I put 0 in for x, the x squared and the 3x go away, and the 2x squared and the -9x, all those go away. So that's just the -10/4. So y will equal a -10/4 or a -5/2. So when x is 0, we have y equals a -5/2. So when x is 0, we come down to a -5/2. Well, writing that as a mixed number, I get a -2.5. So a -2.5 is here. Now, once we find these points, then we start looking for other points to see what's happening. All right, on this side, it's gonna end up going like this. Something like that. To be more accurate, I would find out what happens at -1 and what happens at -10 to see what's going there more accurately. And that'd be easy to do. I put -10 in for x, so that's going to give me a -12 times a -10 plus 5 is a negative 5. And so my numerator becomes what? 60 positive. And my denominator, -5 minus 4 is a -9. And 10, 2 times, no, I was doing -10, right? -10 minus 4 is a -6, a -16. And -10 times 2 is -20 minus 1 is a -21. Three divides both 21. Do this first. 3 divides both 21 and 12. So this is going to be a -7, and this will be a -4. And 4 divides both 16 and 4. So the -4 becomes a -1. And the -16 becomes a -4. And -1 times 5 is 5. -4 times 7 is -7 is a positive 28. So I wrote 22. And so 5/28 is pretty close to 0 here. And if I went down even further, it would come off of 0 and get closer to 1/2. Now, putting -1 in for x, we have -1 minus 2. So this was f of -10. So now we're going to find f of -1, which is -1 minus 2 is a -3. -1 plus 5 is 4. -1 minus 4 is a -5. -1 times 2 is a -2. Minus 1 is a -3. The -3 over -3 go to 1. So this is just a -4/5. So at -1, it's at -4/5, so I had it go down 2 cents. So it's going to skirt along here just above the x-axis and then plummet through and stay close until it hits here, and then it starts diving down. So it's a little more severe turn there than I had drawn. Now, I bet this is going to cross the horizontal axis in here. So one way to find out is to put 1 in for x and then put 3 in for x to find out what happens at those 2 points. I do not necessarily need to find out where this function, what x value gives us 1/2. Or gives us 1/2, because that's the y value we're looking for. Chances are it's a fraction that I don't know. It wouldn't be difficult. It's just more algebra than I want to do right now. And so finding these 2 values, then I have it coming down and through and going down, or coming up and going through and then up. So I put 1 in for x. So now I'm going to find out what f of 1 is. 1 minus 2 is a -1. -1 plus 5 is 4. So my numerator is 4, -4. But I might reduce. And then -1, no, +1 minus 4 is a -3. And +1 times 2 is 2, and 2 minus 1 is 1. So that's a -4 over a -3, which is 4/3. So at 1, it goes through 4/3. 4/3 is 1 1/3, so that's this point here. So it does cross. And this isn't a 0, this isn't a repeating 0, so it will definitely go through. So now we're going to put 3 in for x, and chances are it's going to get it. So f of 3, right? So 3 minus 2 is 1. 3 plus 5 is 8. Divided by 3 minus 4 is a -1, and 2 times 3 is 6 minus 1 is 5. So this is a -8/5, which is a -1 3/5. A -1 3/5 is about here. And so I know this comes down from up there and starts turning through here and goes this way and then turns back down. Right? How you draw these 2 turns is entirely, it might be a more severe turn than I have drawn here. This could be even more gradual. It may come over to this horizontal axis. I mean vertical asymptote faster than what I drew. And now I want to look on this side, and so I'm going to look at this is positive, so I'm going to look at 5, and I went to -10 over here, so I'll go to +10 over here. Right? 5, 6, 7. And so now I'm going to put 5 in for x. 5 minus 2. So I'm going to write it down. I need to erase this. Where I put that. I have limited space. So now I have I want to do f of 5. So 5 minus 2 is 3. And 5 plus 5 is 10. So I have the potential of having 30 here in the numerator. And then 5 minus 4 is 1. And 2 times 5 minus 1 is 9. Well, I can simplify. I can reduce my fraction, my multiplies, before I multiply, and I get smaller numbers. So 3 divides 3 once, 3 divides 9 3 times. So this is 10 thirds. And 10 thirds is 3 1/3. So at positive 5, it goes through 1, 2, 3 1/3. Here. And yeah, I did -1 here to see how severe that was. So I'm going to do 6 to see because it might be 6 may be up here or 6 could be down here. So that really tells us what the curve is going to be. And so I'm going to do f of 6, and then I'm going to do f of 10. So 6 minus 2 is 4. So that's in my numerator times 6 plus 5, which is 11. Hopefully I'll get another even number down here. 6 minus 2 is 2. No. 6 minus 4 is 2. And 2 times 6 minus, oh, that's 11. 2 times 6 is 12. 12 minus 1 is 11. That's quite nice. The 11s go to 1, so they're gone. And 2 divides 4, so that's just 2. So at 6, it's at 2 here. So it's gonna have a pretty leisurely curve here. I bet at 7 is probably gonna be right about here somewhere. But I'm gonna go ahead and do 10, f of 10. So we have 10 minus 2, which is 8. 10 plus 5 is 15. Divided by 10 minus 2 is 6. No. 10 minus 4 is 6. Geez, Thomas. And 2 times 10 minus 1 is 19. All right. 2 divides 6, that's going to be a 3. 2 divides 8, that's going to be a 4. 3 divides 15, 3 goes to 1, and 15 goes to 5. So my numerator is 20, and my denominator is 19, which is just above 1. So that's going to be right here. So yeah, it comes down and makes a not extremely leisurely turn, but it does, and goes like that. And it gets closer and closer to 1/2 the larger x gets. So there I have it. Questions? Please ask questions. This is a time to ask questions. You didn't understand something I did? Ask. If you want me to explain why I did something? Ask. Either type it into the chat or use the unmute yourself and ask. So you're telling me everybody in the class understands everything I do? Okay, I call bullshit. Somebody wants to know why I did something. Or somebody didn't understand how I got that number. Now's the time to ask for clarifications, not the day before the exam. I'll talk to y'all about this later, but y'all aren't asking enough questions. Because I know there's misunderstanding happening. Plus the fact I know y'all aren't doing your homework. So please ask questions. Even if it's just to clarify something. On the next exam, which is in about 2 weeks. This is a type of problem you will get on the exam. As a matter of fact, you're going to get 2 questions just like this on the exam. The functions will be different, but these questions will all be the same. They won't be numbered 1 through 8. They'll be lettered A through whatever. A through H. Nobody has any questions here. Does everyone understand how I got y equals -1, I mean y equals 1/2 as a horizontal asymptote? Does everyone understand how that happened? Keep looking over to the chat. See if anybody puts anything there. Then we're going to understand how we get the vertical asymptotes. In factored form and the reduced factored form, denominator equal to 0 gives you your vertical asymptotes. And on the vertical asymptotes, on one side it goes to -infinity, and on the other side it goes to +infinity. Or they both go in the same direction. They're both to be going up and they're both going down. It all depends on what's happening in the function. No questions? Okay, I'm gonna erase all this and we'll do another one. So we're gonna have f of x is gonna equal x, all right, x minus 3 divided by x squared minus 2x minus 15. Now, do this. We need to factor everything. My numerator is a linear, and there's nothing that's the same in both of those. So it's just x minus 3. If this was 2x minus 6, then I could have factored a 2 out of it. It would have been 2 times x minus 3. And now I'm going to factor the denominator. The leading coefficient is 1, so it's going to be an x and an x. And so the factors of 15, that subtract to 2. Well, that's 3 and 5. 3 times 5 is 15, and 5 minus 3 is 2. But I need to get a negative 2, so it's going to be 3 minus 5. So it's a positive 3 minus 5. There are no factors that are the same, numerator to denominator. Cannot pick and choose numbers up here to go away with numbers in the bottom. It doesn't work that way. This is an entire expression. So if it comes out of one, it needs to come out of the other as well. So this is x minus 3, this is x plus 3. They're not the same, so they don't go away. So it's in reduced form. Now I can set my denominator equal to 0. So I have x plus 3 is going to be 0. And I'm going to have x minus 5 equal to 0. So here I have x equals a negative 3. And here I have x equals a positive 5. So these are my vertical asymptotes. So this is letter A. At negative 3, 1, 2, 3. I have a vertical asymptote. And at positive 5, 1, 2, 3, 4, 5, I have another asymptote, vertical. And now for my horizontal, for letter B, I look at what n is, and I look at what m is. N is the degree of the numerator. The degree of the numerator is 1. The degree of the denominator is 2. And 1 is less than 2. When the numerator has the smaller degree, the horizontal asymptote, what is it? It's something you should know already. Y equals 0. That means the horizontal asymptote is the x-axis. So this is my horizontal, squeaky horizontal asymptote. Now I look for my x-intercepts. I have exactly one x-intercept. The x-intercept happens when the numerator is 0. So x minus 3 equals 0 means x equals 3. So when x is 3, it hits the x-axis. Now, remember, it can cross a horizontal asymptote, but it cannot cross a vertical asymptote. And if it crosses a horizontal asymptote, it's somewhere in the middle. Because the horizontal asymptotes talk about end behaviors. So as x goes very negative, the y values are approaching the x-axis. And as x goes to positive infinity, the y values approach 0. Now, to find the y-intercept, I go back to the original function and I put zeros in for x because these three terms disappear and you just have -3 over -15. So f of 0 equals a -3 over -15, which simplifies to 1/5. So when x is 0, y is 1/5, which is approximately here. Now that we have the asymptotes graph, we have the x-intercepts. Okay. So the x-intercept is 3, 0, and the y-intercept is 0, 1/5. And now I'm going to find other points. And as I find those points, I'm going to graph them. So I want to see what happens at, this is -3, right? -3? -3. And so I want to see what happens at -4 and -2. And come down here to -10, just to see, and I probably would want to do -5 here to see how severe that turn is going to be. And then I come over here to, this is 3, so I look at what happens at 4, and then I would look at what happens at 6 and 7, and possibly 10. So I'm going to start with a 5 and 4, and if those two don't give me -5 and -4, they don't give me a plausible well, it doesn't show me how severe that turn is going to be, then I'll go to 10, -10. So first I'm going to put -5 in. So we're going to do f of -5. And so I always use the factored form. Put -5 in for x for the numerator, you get a -8. In the denominator, you get -5 plus 3, which is a -2. And then -5 minus 5, which is a -10. 2 divides 8, so this -2 becomes a +1. I'm dividing by -2, so this -8 becomes a +4. And again, I can divide by 2. 4 becomes 2, and -10 becomes a -5. And so this is a -2/5. So when we're at -5, we're at a -2/5. So I'm not gonna need this one because I already know how quickly it's coming down pretty quick coming up pretty quick to the x-axis. So now I'm going to see what happens at -4. So -4 minus 3 is a -7. So in the numerator, I have -7. -4 plus 3 is a -1. And -4 minus 5 is a -9. -4 minus 5 is a -9. So this is a +7/9. No, it's negative 7 ninths. Because I have 3 negative signs, I'm multiplying and dividing. And so, let me write this over here a little bit. Negative 7 ninths. And negative 7 ninths is almost to negative 1, but not quite. And so that tells me what this is doing on this side. And to sketch it more clearly, I would look at what happens at negative 3.5, but it's not necessary. So now, I'm not even going to worry about negative 10. So negative 2, I'm going to put negative 2 in for x. So f of negative 2, negative 2 minus 3 is a negative 5. Negative 2 minus 3 is 1. And negative 2 minus 5 is a negative 7. So this is 5 over 7. So at negative 2 is 5 sevenths. So it's right there.
So for the denominator in the equation, is it x plus 3 or is it x minus 3? Because when we were looking at the vertical asymptotes, you put x plus 3.
It is x plus 3. So
Okay.
negative 4 plus 3 is a negative 1. And negative 2 plus 3 is a positive 1. Okay. Because if you do the binomial multiplication here, you will get this back. The same denominator.
Okay, yeah, sorry, I got confused.
That's okay. Ask. It clarifies things. So now we're going to put 4 in for x. So I'm going to do f of positive 4. So 4 minus 3, we get 1 in the numerator. And 4 plus 3 is 7. And 4 minus 5 is a negative 1. So when I put 4 into it, I get a negative 1/7. So it's just barely under. So it's going to come down pretty quick, pretty close to that asymptote, and then make a pretty sharp turn there, and then go through these points. And then when it hits this point over here, it starts doing a severe turn back down. Some of this you can do in a calculator. I just like to do it this way. If you do use a calculator to show these values, please, 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 show me what you're doing. Write it down what you're typing into the calculator. And if you're using the factored form, you really don't need to use the calculator for it. You just do it this way and do what I'm doing there. It's quite, I don't know, I think it's simple. So now we're going to do f of 6. Putting 6 in for x, we have 6 minus 3, which is 3. So we have a numerator of 3. And then 6 plus 3 gives us a 9 down here as a factor. And then 6 minus 5 is a positive 1. So this is just 3 over 9, which is 1/3. So at 6, it's a positive 1/3 here. So at 7, it's going to be less than 1/3, but more than 0. Because that's the nature of the beast. It doesn't cross the x-axis again, so now we're going to find, I'll put it over f of 7. 7 minus 3 is 4, so we have 4 in the numerator. 7 plus 3 is 10. So I'm going to be able to factor 2 out of that. And 7 minus 5 is 2. Wow. So this 2 makes this 4 go to 2. And this 10 and this 2, that's going to be a 5, 1/5. So now we have 1/5. Yeah, 1/5 is a smaller fraction than 1/3. So it's going to come down from up here. I could put, let me see what 10 happens. I bet it's going to be even closer to 0. And so 10 minus 3 is 10 minus 3 is 7. And 10 plus 3 is 13. And 10 minus 5 is 5. So at 10, it's 7/65. 7/65 is around 1/9. So yeah, that's getting even smaller. Not extremely smaller, but that means it's going to be a very gradual descent toward 0. Just like this is going to be a very gradual ascent toward 0. But after a certain point, it starts moving in closer off the path until they look like they're the same line. Okay. Questions? Oh, wow. Questions here? Yeah, I think it's straightforward. It takes what you know. The only thing we really added to being able to graph things is how you find these two types of asymptotes. One is based on what makes the denominator 0, and the other one depends upon what the two leading terms are. What the degree of the two leading terms are. If the degrees are the same, then it's the leading coefficients, that fraction. If the numerator is smaller, then it's y equals 0. If the numerator is larger, then you would not have a horizontal asymptote. You could possibly have an oblique asymptote. Okay. do another one. Let's do one that does have an oblique. So if we have f of x equals x squared plus 7x plus 12, that 2, that looks like a 2. And we're going to divide that by x minus 5. Oh, geez. Okay. So when we factor the numerator, the denominator stays x minus 5, but the numerator, the factors of 12 that add to 7. Well, that's easy. That's 3 and 4. And since we're adding, they both have to have the same sign as a 7. So it's x plus 3 and x plus 4. There's no factors of the same numerator to denominator. So the vertical asymptote depends upon x minus 5 being 0. So that's x equals positive 5. So we have a vertical asymptote over here at 5. But, so 5, we have a vertical asymptote at positive 5. Should make that 2 or 1. So that was A. So B depends upon the leading coefficients of our, the leading degrees, the degree of my numerator versus my degree of the denominator. So we have N and M. The numerator is degree 2. The denominator is degree 1. So the numerator has the higher degree. So it does not have a horizontal asymptote. But does 2 equal 1 plus 1? Well, it does. So it will have an oblique. So we do division. Okay. And the pressed equation is the linear function. And so since it's x minus 5, we have x minus r. So if I do synthetic division with 5, that's what I need to do. So we have 1, 7, and 12. I bring down the 1, multiply by 5, gives me 5. 7 plus 5 is 12. 5 times 12 is 60. And 60 and 12 is 72. That's the remainder. We can ignore the remainder because my my oblique asymptote is x plus 12, which goes off the graph here. So I'm going to change my vertical asymptote because I don't like that. No, I don't like what's happening. So instead of a -5, I'm going to make it +1. No, -1, sorry. So instead of having a vertical asymptote at 5, I have a vertical asymptote at +1. Yeah, that'll give us a nicer slant or horizontal asymptote. See, the process I'm going through right now is the same I do when I create the exam. I want to make sure everything fits nicely on the graph. Doesn't always work out that way, but most times it does. So we're going to use 1 in our synthetic division. So 1 times 1 is 1. 1 plus 7 is 8. And then 1 times 8 is 8. And so that gives me a 20 over here, which I can ignore. So this is x plus 8. Again, I still don't like that, but that's me. And so it's going to go through here with a slope of 1. So that means it goes to the right 1, up 1, or up 1 to the right 1, or down. And so it's going to be this line here. Now, so now we need to find the x-intercepts, and so we did 3. Oh, this is 1 and 2, and 3 is over here. And so 4 is setting x plus 3 equal to 0 and x plus 4 equal to 0. Whatever makes the numerator 0 is the x-intercepts. And so it's at x equals a -3 and x equals 4. So at -3, 2, 3, and at 4, it's going to cross the x-axis. Yeah, I should have thought this out better. Because this is going to, yeah. Because it's going to come like this, and then just sit here and go something like that. Where it crosses the y-axis is at -12 there. -12 down here. Because when I put 0 in for x here, I get a 12 over -1, which is -12. That's number 5 is 0, -12. So this is -3, 0, and this is negative. That's it being -4, -4, 0. And so it's going to come up from down here and come up like this and go from there and go down this way somehow. And so to verify that is to find more values. So putting this is 6, right? -6. I'm going to put -6 in and I'm gonna put -1 in for x. -6 plus 3 is a -3, -6 plus 4 is a -2. -6 minus 1 is a -7. So that's going to be a -6/7, which is about here. So I had it come. So to see kind of more of what's going on over here, I'd come down to -9. -9 plus 3 is a -6. -9 plus 4 is a -5. And -9 minus 1 is a -10. That becomes a 2, that becomes a 1. And so that's going to be a -3. So at -10, it's at 1, 2, 3 here. So yeah, so it's coming down like this. And now it's going to slow its movement towards that line. Now, at -1, we have -1 plus 3, which is 2. And then -1 plus 4 is 3. And -1 minus 1 is a -2. So this is a -3. So at -1, it's at -3 here. So I missed that point. Like I started heading towards it in the first place. So that's going to be a little more severe than what I thought it was going to be. So it's going to peak on this side, just barely over, and then start driving downwards. Okay. Yeah. And then because my chart is off of here, I just want to find out, is it going to be above the slant asymptote, the oblique asymptote, or is it going to be below? And so I'm going to put 2 in for x. 2 plus 3 is 5. 2 plus 4 is 6. And 2 minus 1 is 1. So that's 30. So yeah, that's way above. So it's gonna do something similar to this, but in the reverse direction. Yeah, I would think this out better. I would think it out better. Yeah, I would make one of these x-intercepts on one side and the other x-intercept on the other side of the vertical asymptote. Because then that would bring the slant asymptote between the two. So let's see what would happen there. Let's do some exploring. So instead of a positive, instead of -4, we'll do this. And so yeah. So you see why I don't do this? I don't give you slant asymptotes on an exam. Because it's not always easy to have it be a nice function that fits the graph. So if I was to say this was a negative x, so now f of x equals x minus 4 times x plus 3, this would be a minus 12 here, divided by x minus 1. And so our synthetic division over here is going to be way different. So we would have 1, -1, -12. And so again, and then that gives me a 0 here. And that still gives, and that gives me a -12 here. So x. So y equals x. Y equals x, the identity is the slant asymptote. What x equals 1 is still our vertical asymptote. Yeah, this one's gonna be nice. This one will be nice. My intercepts are +4, 1, 2, 3, 4, and a -3. My y-intercept, right? These x terms go away, so it's going to be -12 over -1, which is a +12. But anyway, so it's going to be up there somewhere. So I'm going to look at, that's -3, so I'm going to come down here to -6 and see what happens at -6. -6 minus 4 is a -10. -6 plus 3 is a -3. -6 minus 1's -7. So we have a 30, -30 over 7, which is approximately what? 7 under 30 goes 4 with 2 left over. So that's going to be 1, 2, 3, 4, and 2 7 negative. So it's going to come through like this. And go up like that. So over here, I want to go on this side of this vertical asymptote, which is 2. And I want to go, this is 4, so I'm going to come down to 8 to see how quickly it's coming towards that way. And so at 2 minus 4, 2 minus 4 is a -6, I mean a -2. And 2 plus 3 is 5. And 2 minus 1 is 1. So this is a -6. So at 2, it's down here at -6. 1, 2, 3, 6. And then at 8 minus 4 is 4. 8 plus 3 is 11. And 8 minus 1 is 7. So this is 44 divided by 7, which is 6 and 2/7. So at 8, I go up 3, 6 and 2/7. So it's going to come down like this. Or go up like that, I should say. They kind of have a similar curve, but they're mirror images, kind of, well, not exactly mirror images. We tend to copy each other. There's some slight differences in there. What's going on? Questions? Yeah, sometimes with this, I start with to write the problem, I start with the vertical and slant asymptote and I work backwards from there. I build a possible. Any questions? How about I know I did a lot of the polynomial ones last time. Which had those a lot of those steps. It had all these steps here. Right. Or if you had a polynomial, there's a lot more to do with a polynomial function than there is to do with a rational function when I ask you to graph them. There are 11 things here I ask you to do. Now, the 11 things I ask you to do, three of them, once you get a number, you have the other three. If I get 3 as a 0 here, then I know x minus 3 is a factor. If I get negative 12 as a 0, then I know x plus 12 is a factor. And then the zeros and the x-intercepts are the same numbers. So as you're finding one of these, you're finding all three of them. And the process I have you go through, or the process I go through, we end up factoring before we find all the zeros. And then this is the easiest one to find. It's the bloody constant. And then I would plot, as I'm doing this, I list as I find the x-intercepts and the y-intercept, I plot those, and that helps me find other appropriate points. Sometimes checking -1 and +1 as zeros gives me 1 or 2 of these points. If they're not zeros, then they're these points. And then once you've plotted all the points, then you draw the graph. You sketch the graph appropriately. A smooth continuous curve that goes through those points. It's not a connect the dot kind of thing. It's a smooth curve. It is a connect the dot, but it's not line straight lines there. So the issue here with this is all these little things you got to find, which are not all that difficult to find. It's just remembering how to do it and what it can do. For the graph, anyway. Want me to work another one of these? I can do that. I like this one. Not because it's a challenge. Oops. Yes, I did remember it correctly. So, oh, that's a cube, not a square. So now I have x cubed minus 6x squared minus x plus 6. Describe the behaviors. Well, the leading term is x cubed. So the end behaviors are gonna do the exact same thing x cubed is, which is down to the left, and up to the right. Those are the end behaviors we're gonna be looking for. That helps us in graphing. Once I know the x-intercepts, the furthest to the left x-intercept, it's gonna go down from that. And from the furthest right x-intercept, it's gonna go up from that. So that'll give us the up and down. Now list all the possible rational zeros. So that means my p values, and my q values, I'm going to use to form my fractions, p over q, which are the rational zeros, or the potential rational zeros. Right? So first thing we got to check, are these all integer numbers on the coefficients? Well, yes, they are. So the p numbers are the factors of 6, which are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. As a side note, 6 is the first perfect number. What do we mean by perfect number? If we disregard the 6 and we add those factors, we get 6. And if we multiply those factors, we get 6. 6 is the first perfect number. Right? 24 is the second one, but I'm not too, 28. Or maybe it's larger than that. I don't remember. I looked it up. I looked it up one time. Okay. Now, the Q numbers are the factors of 1. So that's plus or minus 1. That makes P over Q easy. Because dividing each one of these by 1 is just those numbers. So my ratio, my potential rational numbers are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So if I have a rational zero, it will come from one of those 8 numbers. Each one of these represents 2 different numbers, positive and negative. Now, Descartes' rule of signs. To use Descartes' rule of signs, I also need to find out what f of negative x is. If I put negative x in for x, the sign on my odd degree terms will be changed. So the positive 3x, the positive x cubed becomes a negative x cubed. The minus 6x squared stays minus 6x squared. The minus x becomes plus x. And the constant never changes. That's a big deal. Constant never changes. On the previous exam, people had the sign change on the constant when they put a negative x in for x. No, it's called a constant for a reason. It's constant because it hasn't changed. That's what constant means, no change. So, boom, it stays positive. Okay. Now, for Descartes' rule of signs, we count the number of sign changes, or technically we say the sign variations. Well, the sign changes from here to here once. It doesn't change. It changes again, so it changed twice. So that means we're going to have 2, 4, 0 positive real zeros. And for f of negative x, it's negative, stayed negative, became positive, became plus. So there's one sign change, and then it stayed plus, so there was only one sign change. So there is one negative. Real zero. If we have a positive zero, we will have two of them. And we will have a negative real zero. So we're guaranteed a negative real zero. It could be one of these numbers. Now, checking for negative one and positive one as zeros, I just go up here and I add my coefficients of f of x, 1 plus negative 6 plus 1 minus 1. So I look at those. And I have 1 minus 6 minus 1 plus 6. Well, the plus 6 and minus 6 go to 0. The 1 and minus 1 go 0. So they equal 0. So 1 is a 0. 1 is a 0. Right, yeah. It's a rational number, then it's one of my potential rational zeros. So ooh, we're good. Now I'm going to check for 1, for negative 1. Negative 1, I look at the coefficients of f of negative x. So I have a negative 1 minus 6 plus 1 plus 6. Well, the negative 1 and plus 1 go to 0. The negative 6 and plus 6 go to 0. So again, this equals 0. Well, we have a negative 7 plus 7. So it's still going to be 0. So negative 1 is a 0. Or you could say 1 and negative 1 are zeros. Either way. Well, now I have two of my zeros. I have two of my zeros. 1 and negative 1. That means I have two linear factors, x minus 1 and x minus a negative 1, which is x plus 1. And so that means I'm going to have another 0, right? Because we have at most 3 zeros. We have a positive 0, so that means I have to have another positive. And I already found the negative 1. So what I'm going to do to find that third 0 is to do synthetic division with 1 and negative 1. I'm going to start with the original function, and the coefficients are 1, negative 6, negative 1, and 6. So that's how it is. So I bring down the 1. I multiply as 1. I combine negative 6 with 1. Gives me a negative 5. 1 times negative 5 is negative 5. Negative 1 and negative 5 make for negative 6. And 1 times negative 6 is a negative 6. And lo and behold, I get a 0 as a remainder, which is what's supposed to happen. All right, I divided out x minus 1. Now I'm going to divide out x plus 1. So that means I'm going to do negative 1 on the depressed equation. And I should get a 0 here. So I bring down this 1, multiply by negative 1. Combine negative 1 and negative 5, which is negative 6. Multiply negative 1 times negative 6, which is 6. And lo and behold, it equals 0. Like we knew it was going to happen. Because we found out it's a 0. If it's a 0, then the remainder will be 0. The remainder theorem. We're using the remainder theorem. We're also using the factor theorem. If r is a 0, then x minus r is a factor. And that's one of the 4 statements that you know are true. And here's 3 of those 4 statements. as I'm finding these numbers over here, I know 1, 0 is an x-intercept. I know -1, 0 is an x-intercept. So now I need to do, this is the second depressed equation. So that means it's going to be 1x minus 6 equals 0, or x equals 6. 6 is one of my potential rational zeros. It's positive, so it's my second positive real zero. So that means the point 0, 6 is a 0. 6 is an x-intercept, and 6 is a 0. And x minus 6, which we have it, now we have it totally factored. What's the y-intercept? Tell me what the y-intercept is.
0, 6.
Yes, it's the easiest thing to find here. It's the constant. Now, to list other appropriate points, well, to do that, I start graphing. So I have -1, I have +1, and I have +6. -1. They all have multiplicity of 1. They're not. So that means it's going to go down from here, and it's going to go up from here. It goes through +6 on the y-axis. And so it's going to come up like this, and then come back down like this. And so somewhere between here, so I'm going to do 3 and 4. So I put 3 in for x. So 3 minus 1 is 2. 3 plus 1 is 4. And 3 minus 6 is a -3. So that's going to go down to -24. So way down here, -24, and then putting 4 in for x. 4 minus 1 is 3. 4 plus 1 is 5. And 4 minus 6 is a -2. So that's going to be -30. So that's down here. And so it's going to come down like this and go through there, and then come back up and go through there. And I would change my y scale to fit these numbers. So I would sponge it down. So +6 is going to be up here somewhere. And so it would go like this. So my scale, my y scale would contain those points. Okay, what I want to do right now, because I'm running out of time, and I meant to stop this sooner. MyLab is there for a reason. And a lot of you all aren't doing it. And the grades on exam 1 are showing it. Not doing MyLab, not doing the homework hurts your grade tremendously. Because there are people who haven't even signed in and done any of the homeworks. And those are the people who did the worst on the test. So please do the homework. Your midterm grade is based on two things. The number of homeworks you're doing. Are you in there doing the homeworks? Yes or no? If kind of, not really, you've done 4 or 5 homeworks, well, that's not actually being consistent with doing your homework. And your grade, if you know, the grade on this exam had been abysmal. Out of my 3 college algebra classes, I have 4 grades above a 60. I might have more, but it's not many. And so out of about close to 60 people, only a handful or less than 2 handfuls are making above a D, or making a D or above, is horrible. And I feel bad about this. I feel like it's my fault for not being in your faces enough to get the homework done. Okay, let me shut this down. I should have been on your backs more about doing the homeworks and being there and doing the homeworks. I haven't been very good about following that. There's a lot been going on in my personal life, which is no excuse. That's just why it's been happening. Yeah, a lot of y'all are going to get early alerts, or if y'all are early college, high school students, you will get a D. And you might get higher depending upon what your grade was on the test and the homework, how much homework you've done. But all the D means is you need to be in there doing the homeworks. I will do something so you can make up this grade to be passing above a C. But that would be a little bit later after you're doing more of the homework. So I'll put in quizzes in my lab. I'll put in some things in there for you to go in and do to help improve your grade on that exam. So yeah, I want y'all to pass. I want y'all to do well. I want you to understand this material. And whatever I need to do to help you understand it, I'm willing to do. Khan Academy is a wonderful website. For it has it has tutoring videos. It also has interactive stuff. .org. So it's a free website. It is very powerful and very useful and very helpful. Please, please, please do not hesitate to use any tutoring available for you. Do it. Get into my lab. Ask the professor. Use it. Ask questions during class. Stop me if I've gone too fast or too far, or you need to look at that last slide again. I get crazy. I start going too fast and I don't realize that I left half the fast on. Please tell me that, Mr. Reed. I need to either in the chat or come on mute and yell at me. Tell me to stop. I'm going too fast. I had one of my first college professors, math professors. He said that, and it was so true. He gets so excited about what he was talking about, he was screaming by the end of the class period. And he said, please, if I start doing that, tell me, Mr. So-and-so, you're starting to yell. And he would back off. We would tell him that, sir, you're getting all loud. And so he would back off. Yeah, I'm the same way, except I get going faster. I don't necessarily get louder, but I get going faster. Please slow me down by telling me I'm going too fast. or I need to go over something again. Okay, I had someone last time with the graphic of the rational functions. They didn't understand how I got certain values. And so I went through and explained how I did that again. Doesn't matter. I don't care if I do it 25 times. I explain the same thing over and over again. Doesn't matter. What matters is that you understand it. Ask me questions. Ask the professor or ask the instructor. Use Khan Academy. Use, if you're on campus, use the math lab or use the STEM lab. You have plenty of opportunities to find a tutor, a free tutor here at SAC. If you're in the high school, you should have opportunities for finding a tutor there. Or use me. Do not be too worried about what's happening with your grade right now. Be worried about what's going to happen later on, because that's most important. Make sure you stay current with your math lab. Make sure you ask questions when you don't understand. Make sure you ask questions or ask for clarifications when it gets confusing. Or if I'm leaving you behind, tell me and I'll slow down, or I'll back up and go over it again. I don't mind doing that. I know there's some people who go, oh God, again. Well, too bad. Some people need it to go over again and over it. So please, 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 do the homework. Do the My Math Lab, or My Lab Math is what it's called. I still call it My Math Lab. So I'm going to get off my high horse here. We've been 5 minutes over, which is okay. So I hope I haven't hurt anybody's feelings or I haven't upset anybody, but this is serious. I need y'all to pass, not for me, for y'all. I need you to pass. And for you to pass, you have to understand the material. And to understand the material, you have to do the homework. I'm not using those grades directly. My first calculus class, the professor said, do the homework. That's where you'll, because he never picked up the homework. He didn't do what I did, what I'm doing, which is the grade from your homeworks I use to help boost your grade if you make less than an 80. Very few people did that this time. So don't fall into that trap. I've had a bunch of people drop my classes this time, much more than I ever had in the past, because they're not doing their homework to stay current. The only way you can stay current and anticipate what's coming ahead is to stay current with your homework. If you fall behind on the homework, it gets very hard to bring those grades up. So start now. Yeah, stay with what we're doing now, but also start bringing that other homeworks up and finishing those other homeworks. And if you need to go ahead and go. We're past time now. Like 5 minutes. So I'll see y'all on Wednesday. Hope y'all take care.
You
See you
too,
once.
sir.
Y'all have a great day. And I'd have no clue what happened to that hat. I love that hat. My wife and daughter laugh at me every time I wear it. That's one reason I wear it. Okay. I'm going to end the meeting and I'll see y'all later.